Had to trim that down a little bit. Let's go on now. We're going to do logarithmic functions. These are the additional exercises, and we're going to see if we can fit these words in there. Again, there's only 4, so it's not too bad. Let's see what we can get. The inverse of an exponential function, we said, was its logarithmic function, so that goes there. Log base 2 of 8 is the what to which we raise 2 to get 8. That's the exponent. Base 10 logarithms are called common logarithms, and log base 10x is abbreviated log x. If it's 10, that is the common logarithm, we don't have to write the 10. Okay, now we get to play with, practice with some of these items. Now, if we worked on anything here, hopefully we worked on a pattern to do this. So our base is 10. 10 to what exponent will equal 100,000? And let's just set them up like this. Base 4 to what exponent will equal 64? Base 8 to what exponent will equal 1/8? Base 9, log of 9, to what exponent will equal 9? Base 5, to what exponent will equal 1? Base 25, to what exponent will equal 125? So again, you've developed a pattern for translating logs into this exponential form. Now, change color here. 10 to the what is 100,000? 10 to the 5th. 4 to the what power is 64? 4 to the 3rd. 8 to the what power is 1/8? That would be a -1. 9 to what power is 9? Yes, you're saying 1. 5 to what power is 1? And you're saying 0. Now, this one's a little tricky because it's actually a fractional exponent, 3/2. If you recall that from chapter 7, the square root of 25 to the 3rd power. So our index number goes there. Our numerator, which is the exponent, goes there. And the square root of 25 is 5. And then 5 to the third power is 125. Okay, again, filling in your booklets and knowing these and keeping them as a model will help with mastery. Okay, they ask us to graph this by hand, and there is our inverse. So what this represents is our base 5 to the exponent y, and that's going to equal x. So as we set up our t-chart, what we're going to do is put in values for y, which I did remember this is inverse. So again, 0, 1, -1, 2, -2. And then if y is 0, this is going to be 1. X is 1. 5 to the 0 power is 1. If this is 1, this is going to be 5. If y is a -1, it's the inverse, which is 1/5. And then if y is 2, we square 5 and get 25. X is 25. And if y is a -2, we get, again, the inverse, 1/25. So then I start plotting my points. X, 0. X is 1, 0, right there. 5, 1. I go over 5, up 1. Now I go over 1/5 and down 1. Then I go over 25, which is off my graph, and I go up 2. So I can kind of sketch this part of the curve now. And then I sketch this other part. And your y-axis is the abscissa, you may or may not recall. Okay, this one is done in a similar fashion. It just takes a lot of time, but that's how it's done. And the graphs I've worked out for you. Let's go on. If you look at the answer, and again, it's hard for me to sketch these in. One is the inverse of the other, and your axis of symmetry is y equals x, and they are reflections. Okay, here they're asking you to use a calculator to find the following and round them to 4 places. Again, I'm not quite sure how we're going to be doing that. And then graph using a graphing calculator. We'll pass that one up too. Okay, here they only want us to write an equivalent exponential equation and do not solve it. So let's work on that. And here again, a pattern would be, there's our base. It's going to equal 8, and m is our exponent. Our base is 5. It's going to equal 0.2, and our exponent is a -1. And again, the general form, a is our base. It's going to equal t, and our exponent is p. Okay. And for this one, I didn't write it out, but our base is e. Our exponent is this. And that will equal 0.4. Okay, so again, not too bad. Hopefully you're developing a pattern. And let's work on these. Again, we want to rewrite each equation as an equivalent logarithmic equation. Do not solve. Well, in the other lesson, the PowerPoint, actually I solved them, but I will follow what they're asking me to do here. So I could have put a 10 here, but since this is the common logarithm, remember we don't have to put our base 10. And then here our base is 27, so the log of base 27 of 9 is 2/3. Remember, this is the exponent out here. And you can just check your work. And pause it if you need more time. Now here they actually want us to do some solving. So let me set these up. So as we do these, we have our base 2, exponent is 4, is what? Well, 2 to the 4th is 16. X equals 16. Our base here is 5. Our exponent is x, which is going to equal 125, which is actually 5 to the 3rd. 125 is 5 to the 3rd. So we now have this x equals 3. And a few more here. So here our base is x, our exponent is 1, and our answer is 1000. So our exponent is 1. This is to the first power. So x equals 1000. Now here we have our base of 81 to the 1/2 power. X is to the 1/2 power. And here I think we can just take the square root of this, which is that, and that would be 9. So x would equal 9. All right, let's see if there's any more. I think we ran out of examples in our book. And that should take care of it. Our next thing is we're going to work with logarithms of products, powers, quotients, and using the properties together. Oh, this will be more challenging.